Hello, my name's Julian Edgar and I'm the author of the book Car Electrical and Electronic Systems. What I want to do today in this video is talk a bit about using a multimeter. Now, if you do any work on the mechanics of your car, you need tools. You'll need a socket set, you'll need screwdrivers, you'll need pliers and so on. The same applies to doing any work at all on car electronic and electrical systems. If you don't have a multimeter, you're going to be blundering around in the dark. It's very, very hard to work out what you're really doing. So a multimeter is an absolutely vital tool that you need. So here's an example of a multimeter that I use. It's a Fluke multimeter. I've had it now for a long time, 7 or 8 years. I've also bought a more recent one which also does logging, but this still remains a very, very good multimeter. I'd suggest that when working on a car, I'd use it nearly every day. So when you watch someone use a multimeter, it can all look a bit complicated, confusing, difficult, bewildering even. But most measurements that you make with a multimeter, I'd say 90% of the measurements I make are just of what is called a simple DC voltage. The sort of voltage that's produced by the battery in the car, the sort of voltage that's also produced by most sensors in the car, engine management sensors, not all, but most engine management sensors and so on. When you're measuring voltage with a multimeter, it's really very straightforward. Remember, that's the majority of measurements that you do. In almost every case, the negative lead, the black lead, is connected to chassis ground, effectively to the negative of the battery. And it's the other lead, the red lead, the positive lead, that you use to probe to find the voltage. So at its simplest, you might connect the negative lead to the negative terminal of the battery and touch the positive lead to the positive terminal of the battery and read battery voltage. It's probably unlikely you're going to be doing that. That's not actually all that common a use in the real world of working on cars. Much more common is more likely you're going to be grounding the negative lead and perhaps probing the output of the throttle position sensor or something of that sort. To do that, you'd pull back the boot if it's a traditional throttle position sensor so you can access those connections, and you'd put the positive lead into one terminal at a time, remembering the negative lead of your multimeter is grounded. So what might you see on the meter when you do that? Well, one of those probes, one of those connections might show 0 on the multimeter, or a very, very small voltage, and that's probably the ground terminal. One next to it might show 4.98 volts, or something very close to 5, and that's the regulated voltage feed to that throttle position sensor. Another position on a throttle position sensor connector might show a voltage, and that voltage varies as you open and close the throttle. So that's the signal output. So why would you want to do that? Well, if you wanted to tap into that signal wire to do something else with it, operate an electronic switch or something like that, you'd need to find out which one was the signal wire. If you wanted to make sure the throttle position sensor wasn't faulty, you'd tap into that wire temporarily with the probe, you'd read the voltage, and then you'd change the throttle position opening and make sure that voltage smoothly changes at the same time. Any big jumps or any gaps in the voltage output shows there's a problem with that voltage sensor. So measuring DC voltages makes up a huge proportion of the sort of work you do with a multimeter on a car. Another thing that you can measure using your multimeter is current. How many amps are flowing? Now, you've always got to be careful when you're using a multimeter to do this. Firstly, the multimeter almost always needs one of its probes moved on the body of the meter. So in this particular one, you actually have to take out the positive there and move it across to one of these two terminals if you are going to be measuring current. The second thing that you need to keep in mind with a multimeter measuring current is the meter is inserted into the circuit. It's not just connected externally like we did when we were measuring voltages. It's connected in series in the circuit. So all the current has to flow through the meter itself. That's how it makes the measurement. Now, if too much current flows through the meter, you'll blow its fuse internally. Nearly all multimeters are rated to a maximum of 10 occasionally 20 amps, but that's usually only for a very short time. So you can't use a normal multimeter to measure the current draw of the starter motor, for example. You need to do it in a different way. When you measure current, the absolutely key thing to remember is that when you finish the process, move the plug back to the original location, the voltage location on the multimeter. Otherwise, next time you go to use the multimeter to measure a voltage, you immediately blow the fuse in the multimeter. Why is that such a big deal? Fuses for multimeters tend to be quite expensive. They're not as cheap like a blade fuse or a normal glass fuse because they're a high voltage fuse. So we can measure voltage, that's the vast majority of what we do. We can measure current, remembering we've got to move a probe and then remember to move it back afterwards. We can also measure resistance. Resistance is measured with the multimeter in its voltage measuring position. But the key thing to remember when remembering resistance, say you're measuring the resistance of a coolant temperature sensor or something like that, is it must be unplugged. It must be separate from the circuit. Don't try to measure resistances when they're all still connected because it's probably going to be the wrong reading. There's two other things that good multimeters can measure, and they're often very, very useful. You measure them on the voltage setting, but you normally press at least one other button. The first thing is duty cycle. In one of the other videos I talked about varying duty cycles of injectors. What proportion of the time are they switched on for? If you put the multimeter across the injector, you can measure duty cycle directly, saying it might be 2% at idle, 50% at half load and so on. That's useful because it shows the signal is actually getting to the injector. In the same way, you can measure the duty cycle of valves such as boost control valve, idle control valve and so on. The other thing that you can measure along with duty cycle is you can measure frequency. How often the valve is turning on and off, or how often the device is turning on and off. Frequency and duty cycle are often useful if you're diagnosing problems, if you're comparing it to values in a workshop manual, or if you are making changes and want to see what the result of those changes actually are. It can all look really complicated using a multimeter. In the book I have a whole chapter on using multimeters. I cover each of the things that I've described here, showing diagrams as to how they should be put into the circuit. I also show different types of multimeters. It's an important chapter, I think, because really you're using a multimeter almost all the time when you're working on electrical systems in a car, and you want to be really confident in what you're doing, confident in the measurements that you're getting. Thank you.